This is a demonstration of this simple divider circuit. This circuit uses a sequence of subtraction to complete the calculation of division. This is not a particularly fast way of division. The shift and subtract method is much faster. First, we have these two registers to store the result of the calculation. This one stores the quotient, and this one stores the remainder of the division. Here are two 8-bit switches which act as the input data. This one holds the number to be divided, and this one is the 2's complement of the divisor. Now, because we use subtraction, so we need to take a negative sign of the divisor. So we have to plug in the 2's complement into this switch. Next, these two are adder chips, and it will sum up the 2's complement of the divisor and the partial remainder stored in the same register as the remainder of the calculation. This chip is a counter. It will track down how many subtractions we have done, and the result of the output of the counter is stored in this register, which is the quotient. These two multiplexers will select data to input into this partial remainder register. At first, we will use this red button to switch the multiplexer to use the input and put the input into the register. Next, we release the red button, so the multiplexer will select the sum to put into the register. Now we can just give the clock pulse with this black button. And when the sum becomes negative, the first bit in this wire will become 1, and it will reset this latch and cut off the clock signal with this AND gate. So the counter and the registers will not update anymore, even if I give it any more clock pulses. So now we have the result of the division in these two registers. So what we have just calculated is 37 divided by 9. That will result in 4 and a remainder of 1.